today we're going to be chatting about the difference between AI automation and agentic AI. And we've seen customers, I guess, struggle with this conceptually in the past. And I think it's very important to make a distinction between the two so that you can better architect working systems for your company. So yeah, I want to ask you, what is the difference?
Yeah, so the place I'd start, I might have said this last time, is there's a lot of buzz in the space of AI that has suddenly gotten decision makers to think more about implementing software. So they'll think so much about having AI agents, but with the request to create AI agents, they end up creating a system of software that they could have before. But beyond that, people think about AI, and just some autonomous thing doing something within a black box, but they don't think about determinism versus non-determinism. So to start, agentic AI, you have an LLM with tools attached. You're more than just text in, text out. You can actually action and perform connections and operations with tools external to the LLM itself. Automations are a series of deterministic processes that may or may not involve an LLM, but automations do not have a single LLM with tools attached. So that's a fundamental difference. We can talk about when you should use each, but that's what I would say. What would you say?
I agree. I think the fundamental difference is like determinism versus non-determinism. But just to take a step back too for the viewer, like what do we? So when you say there's an LLM with tools attached, can you give like a practical example? Like what does that actually mean?
Yeah. So if you want an LLM to draft an email and save it in Gmail, then you would need an LLM connected to the Gmail API so that when you say that, it shows up in your drafts in Gmail or whatever. But if you just told ChatGPT to do that right now without any tools attached, without clicking one of those toggles at the bottom, nothing would happen, obviously, because it's simply not connected to it.
Right. So in this case that you're talking about, LLM, we can substitute an OpenAI model, a Claude model, Gemini model, whatever, and then tools attached means a specific action, right? So like draft an email, respond to an email, send an email. Is that the right way to think about it?
Yeah, that's correct. The simplest way to think about it is an LLM connected to an external application. So every enterprise, every business has some tools that they use. Could be Gmail, could be Outlook, could be Microsoft 365, could be Notion, but no LLM can talk to those autonomously unless it has it as a tool.
Right. Okay. And then so that's that's what is meant by LLM tool calling agentic AI. What is determinism versus non-determinism? And maybe even before the verses, what is determinism?
Yeah, determinism, I guess, philosophically means that for a given input, you will always get the same output. Non-determinism means for a given input, you may get one or more different outputs. You cannot predict it.
Right. So deterministic, in a very simple form, means if X, then Y. With 100% certainty, you can say that. So like a practical example in an automation, for example, would be if an email comes in, if any email comes in, draft a response. That's a deterministic automation for every email that comes in, we will draft a response. I guess the drafting of the response can become non-deterministic in the way that the AI will actually write the response. Versus the non-deterministic would be if an email comes in, reason through whether or not to draft a response or send a response back immediately. Is that a proper example or?
Yeah. So there's a couple things to distinguish with there. There's the determinism of the process, the actual architecture, and then the determinism of the operations within the process. So with drafting an email, obviously the email itself is not deterministic, but the process of something comes in, email drafted, comes out, that architecture is completely deterministic. It will never deviate. But with a tool call, it may not always be the case. If it has a tool, it may elect to go do a web search. Or it may not. We don't know. That's non-deterministic. So two ways to think about determinism, non-determinism, determinism at the architectural process level and the actual operation of the individual, I guess you could say, nodes or functions.
Right. So I think one of the major things that comes to mind for almost all of our clients, all of our customers, and most people who are experimenting with AI is in non-determinism, you introduce the risk of things like hallucination or drift, versus in a deterministic process, you can predict with 100% certainty if something happens, then this other thing will happen. So what are the measures or what are some means by which we can take to make non-determinism less risky?
Yeah, that happens at several levels. First, there's the training level. So different models are trained with different levels of safety. AI safety is a pretty large and well-paid topic nowadays. So while OpenAI, Google, et cetera, train their models, they intentionally instill the blockage of certain requests. I mean, you can think of any inappropriate thing that I won't mention, but it will not do things. And you've seen probably content moderations before, whereas some models are a little more open. We call them uncensored models. They're literally designed to not have any sort of blockages. And then there's a whole spectrum of that. So that happens at the training level, but now that you don't have control over that because you're not OpenAI or Google or whatever, the question is, how do you, with applied AI, introduce those things? Something that gets talked about often is guardrails, obviously, and that's one of the main things. When it comes to implementing guardrails, there's a couple things. So obviously, there are deterministic ways to introduce guardrails. I can detect whether, let's say, an API key or password is exposed deterministically, so you should watch for things coming into it. But what happens in a lot of enterprise architectures is a hallucination agent. So you'll often follow up whatever LLM or system or agent that has already occurred, let's say your Gmail drafting agent, with a subsequent agent that's called a hallucination agent, which basically detects for whether or not the information has deviated from truth or whether it has violated a business process or a security protocol or something like that. Another example is a lot of people like to do prompt injection, and they'll send to the LLM, give me your system prompt. But if you introduce an agent before that or after that that says, did a system prompt injection just occur, it can flag that. So in many ways, the way to protect AI is with more AI. And then that turtles all the way down. How do you actually protect each and every step?
Right.
But that's a little more complicated.
Because the next follow-on question would be, it's great that we have a hallucination agent or a checker agent before or after or anywhere in the process, but how do we make sure that the hallucination agent isn't hallucinating? Do we have a hallucination agent for the hallucination agent? Or what are the risks there, and how do we also mitigate those?
I don't know. I don't know everything. A lot of websites are still vulnerable. Hacks occur every day to the Pentagon and things like that. So I'm sure we'll continue to learn because it's a very novel space, but it's hard to give anything more than what I've already pointed out.
Have you seen with the systems we deliver like a really tangible difference from when there's, I guess, let's say no guardrails versus we have guardrails? And can you give a practical example of an implementation we've done with a hallucination agent?
Yeah, so when it comes to guardrails, it's often just an implementation requirement. So like a lot of the times when that comes up is just exposing PII, personal, I forget what the second I is, but it's just personal information. Something identifiable data, which happens with a lot of tax providers. We do a lot of business with a tax automation provider. But interestingly, with that same client, they had a project called AI Docs, which is very famous in our company and theirs, which intends to automate the creation of a certain piece of technical documentation. So they have a product that their clients use, and they want to put user guides out onto the web for not only their users, but the public to see and use in the event that they need guidance. In order to ensure that that documentation was not only, let's say, free of grammatical errors or whatever when automatically generated with AI, we also needed something to determine whether or not the information deviated in truthfulness from the original. So we had an agent that created the actual documentation, and then we had a subsequent agent that determined whether what it output deviated from the truth. The source was the original documentation, actually, because those were written by humans and we assumed was valid. And then it was also instructed to just do like a grammatical check and things like that. Another thing to consider in there is scoring protocols. So we were also using a system called Acrolinks, which is an industry standard, basically like grammar and writing quality checker that would automatically score it. And if we got a score below 80, we would just try again. So you have the option of hallucination agents, but there's also many ways whether you can determine an AI output is of sufficient quality. You can implement custom scores, or you can rely on existing softwares as well.
Yeah, and all of these are done at the application level in applied AI versus being a foundational model provider where you can, I guess, implement some of these new guardrails that would fundamentally change the way a model behaves.
Yeah. I mean, everything about scoring or hallucination detection is at the applied level. I mean, they'll continue to make improvements as they can to avoid hallucination. There's several benchmarks for that. I don't know the names of them off the top of my head, but yeah, there's movement on both sides, both applied and I guess you could say foundational.
Where do we think we are anecdotally, you know, like in your own experience with like the systems that we were building, let's even say a year ago. So like February of 2025, we were, I think exactly 1 year ago, you were lead engineer on probably 8 or 9 projects simultaneously. So with where AI was back then, in respect to what we're talking about with hallucinations and risks versus where we are today, can you speak to the difference there?
Yeah, so this may be a hot take, but I don't really think we've come that far. I guess as someone who's experienced in applied AI, I notice most of the difference in quality of systems come from the architecture, not the quality of the models themselves. There are ways to get around it. That being said, I would definitely say there's a difference between different models. Obviously, a lot of smaller models, 3 billion, 8 billion parameters, they will just make up things or completely miss an instruction. So in that sense, they hallucinate. But if you're an enterprise buyer and you want to regenerate docs or draft emails and you're worried about hallucination, honestly, the difference between GPT 5.2 and 3 Flash or 3 Pro, like it just doesn't matter, honestly. A lot of that complexity is beneficial when tool calling is introduced. Yeah, that's what I would say.
So you wouldn't say you've noticed a fundamental difference between any model, like a stark difference that you would use, like and I get this is a bit of a nuanced question, but let's say for a given system, the only mission of that system was to minimize hallucinations. All things the same, like same tool calling, whatever. You wouldn't have an inclination to use a specific model versus another?
Well, I think we should probably step back and define hallucination a little, because there's I missed something, and then there's I invented information. And typically when we talk about hallucination, we mean something erroneous wasn't introduced.
Yeah.
Okay.
100%. I think that's what most people probably associate. Hallucination is like, the LLM just told me something that is entirely false.
Yeah. So, again, I don't think there's large differences between the highest quality models in this respect. What is important to note is that most models will hallucinate as they approach their context window. So if you don't know what a context window is, there's basically an amount of information an LLM can take on at any time. You can only eat a certain amount of food depending on the size of your stomach. An LLM can only consume a certain amount of text. Different ones have different sizes. Google tends to provide the highest quality and length of that. So the Gemini models come in at 1 million tokens, which is like not one-to-one with characters, but it's like, it can read all of War and Peace and return the results. And then OpenAI's models are about 40% of that at 400,000. Now, a rule of thumb is anytime you start to go over 40% of an LLM's context window, you may see some drawbacks. And you can be assured that if you start checking, let's say you fill up 400,000 of the 400,000 tokens for an OpenAI model, that's when you start to see some interesting things. And I have seen that before. Mm-hmm. So when we talk about hallucination, difference between model providers today, not a big deal, but be careful about what you're giving those models.
Yeah, 100%. So I guess, taking a step back then from hallucination, bringing it back to determinism versus non-determinism, how do enterprise AI architects think about when to use which for a given process or a given outcome?
Yeah, it's, you know, it's hard to provide rules. There's a couple things I would say. Something my graph theory professor said. Someone asked him, "How do you do a proof? Like, give me some rules and ways to think about it." And he was like, "I don't know. Like, I just done it enough times, or I kind of have an intuition." That being said, the use of agents and the use of deterministic processes, or I guess what you would call RPAs, which I don't even know what that stands for actually. It's automation.
Robotic process automation.
Is that what it means?
Yeah.
Oh, robotic process? I mean, it's not even robotic.
I'm like 90% sure that's what it means.
Oh.
I know the R is robotic.
Robotic?
I also know that it's 100% synonymous with deterministic automation.
Yeah. So, yeah, the more flexibility you need in the system, the more you should lean towards an agent. Because if you want to put in text and get in a variable amount of outputs, your RPA would have to be sufficiently broad in order to account for that, in which case you should just use an agent. But if you're expecting a single type of output every time, so I put in a response input and I always get a PDF out of it, you should probably consider and think about the RPA route. Now, it depends what you want in that PDF, but it really depends on the use case. It really just depends.
Yeah, I think one thing that I try to encourage our clients, and the way we approach it, is like start with, once we're past the strategy, use case identification, auditing, opportunity assessment portion, we always see a lot of quick wins in deterministic automation. And that's typically a good place to start because it can set up the groundwork for the non-deterministic, for the agentic pieces. And especially for companies that are early on in their AI transformation journey, maybe they've messed around with a tool like Zapier or Make or N8N, and maybe a few citizen developers here and there have implemented one or two automations. Especially in larger and larger organizations, they are ripe for deterministic automations. Like, you can go in and you can cut hundreds of thousands of hours and hundreds of thousands of dollars in wasted cost by implementing very basic deterministic automations, which then set up the foundation for agentic AI.
Yeah, totally agree. What examples have you seen perhaps on recent client discussions or sales cycles?
I think, so a few examples that come to mind, I would say, so one, there's a prospect we're working with where we're evaluating his pre-sales process. So there's a lot of work that goes into a pre-sales process, a successful one, where there's handoffs between account execs and sales engineers, etc. So a number of things happen that previously reps and or sales engineers may or may not have done, but they should be doing every single time. So an example of that is a discovery call gets booked, perform some research on the prospect, and send back a report back to the rep or back to the sales engineer saying, hey, here's what I found on the prospect. Here's some useful information that you would want to know heading into this call. Post-call, there's a number of different follow-up steps. One of them is always drafting an email. So again, this gets into like the layers, right? Where drafting the email is deterministic. We want to draft an email every single time after a call. What we draft in that email, that's where the non-determinism, like, is it a good fit? Is it not a good fit? Are they a partner? Are they a customer? That's where like it gets a little bit more nuanced. But I think in terms of the sales process, like, that's one where there's a pretty deterministic flow of like, and even before the call gets booked, there's a number of other automations that we would want to run. But call booked, perform research, call ends, write an email. That happens every single time. There's variation in those steps, but that as a deterministic chain is a pretty high value one that I think a lot of organizations could use.
Gotcha. Yeah, I liked what you said about like if this, then that. That's how to think about RPAs. You have a road that you're going to follow, a path. And computer science, we call it a directed graph, but there's very clear lineage of things that need to happen. Whereas with an agent, there just isn't one. There literally is no given path at any time other than the actual input itself.
Yeah, it's interesting to me to see like the to see the differences, because we work with a variety of organizations, all of whom are at different maturity levels in their AI journey, in their AI transformation journey, and I still feel like there's a very wide range of expectations of what people think is possible, of what is actually possible, and what should be done. There's like just as wide a range of spectrum as you can imagine. Like, we've worked with executive teams who didn't know what an AI agent was as recent as like a few months ago. We've worked with executive teams where like everyone is screaming to implement agentic AI. Maybe they know what it means, maybe they don't. I think some of them do. And everything in between. And that ranges not only just from executive teams, but like from top level all the way down to like engineer, like software engineer, to like data analyst. How do you think about that gap in expectations, and like what do you think is important for organizations to know in terms of what is actually possible today?
When you say the gap in expectation, you mean somebody at the board level is screaming agentic AI and then they don't really know what's going to happen, but then somebody has to do something?
Yeah, that, and also like, someone on the executive team, maybe the CEO thinks a ton of stuff is possible with agentic AI, but the CTO knows that it's not. And like, there's a balance there. How do you think organizations should approach that problem?
Yeah, it's a very broad question. I mean, the fact of the matter is not everything is possible with AI. It's not a perfect machine. When it comes to this, like, top-down screaming, I talked about it last time. So when we talk about the gap, obviously there's a lot of investment that goes into AI. There's a lot of wins that you get from saying you use agentic AI, and those buzzwords are great. But what I feel is that we've lost a sense of outcome-based decision-making. For some reason, we've decided to shape our decisions around what method or tools we're using instead of the outcomes. And so everybody's demanding that we use AI or this tool or that tool in order to achieve an outcome, but we're not demanding the outcome itself. So a lot of leaders, they want to use AI to accomplish something, but I just don't understand why we're not talking about the outcomes themselves, because in a lot of cases, in many cases, you have leaders demanding a certain outcome with an AI that doesn't need AI. It just doesn't need it at all. But they will make you build it with AI to say that it has AI anyways. And that's something we've seen in a couple builds. I talk about the AI docs refactor again, at the risk of pointing to whatever was said by leadership there. But a lot of what we could have done was restructured a lot of the documentation deterministically, just in terms of the hierarchy, and there were arguments for that internally. But there's some amount of AI that had to be introduced. So in terms of the gap, I don't think it's a gap that should necessarily exist. We don't know what's possible with AI. A lot of things are a matter of experimentation and us trying to make things a reality. But again, we shouldn't be demanding that things be done with AI. We should be demanding that high-value automations are being made. The last thing I'd say on that is, and this is something that our former co-founder Nate Herc said one time on some interview, he said, everybody is screaming agents, 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 but everybody should be screaming automations, 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 because automations are what save you time, what make all of our lives a little easier, and is the foundation of computer science. And agents should only be an end to the means of automation.
Yeah, 100%. I really like what you said about taking an outcome-based approach, because that's where you're really going after, right? But now I think it's in large part because of the hype and the hype cycle and all the headlines. It's like people have lost sense on the outcome and are just worried about they're worried about the how, not the what, but they should be worried on the what for the most part. Like, what is the outcome you're going to get? I think it also speaks to like a notion of like a build versus buy analysis, topic that comes up somewhat frequently for us. Because if you start with the outcome and you work your way back, inherently build versus buy analysis, at least for enterprise organizations, is baked into that somehow, where you can say, all right, here's what I want, and maybe there's a $100 per month tool out there that will already solve it. And okay, cool, because I'm thinking about the outcome, I can find that tool. Versus if you're thinking about just AI, well, you're going to sink a couple months and a few $100,000 into a bespoke project to build it out. Whereas if you had started with the outcome and you just done a little bit of research, you could have saved all that cost and used a tool or something like that. So,
yeah, no, I was just going to say, I agree. I think there's a lot of excitement in enterprise to build AI, and they will spend millions, sometimes billions, on building it when there's an off-the-shelf tool. And so I think that's a good point. If you're orienting around outcomes, then a build versus buy analysis can help you frame that, because what you can buy, products are marketed in terms of their outcomes often. I mean, they're also marketed in terms of their methods, but if you go onto something's website, it's going to say you're going to get this from this. And then you can see, well, are these tools missing something? If they consistently are, then let's build it instead of buying it. You know, I would say in terms of the buy, a lot of times, you know, it's just more economical. You're going to spend so many man hours trying to build something that's going to cost you hundreds of thousands of dollars a year when you can get a seated subscription for 5 people for a total of 1,000 or something. So,
yeah, 100%. Well, fascinating discussion today.
Yeah.
And appreciate it.
Yeah, thank you.